guys, today we are on lesson 17, apply rounding. So Friday we spent a lot of time rounding and reviewing so that we would be ready for today. Today's learning goal: let's round large numbers to learn about situations and solve problems. All right, our warm-up is page 74. Are you all on 74?
Yes.
Okay, it says, what do you notice? What do you wonder? So you're looking at this two-column table. It has, these are all names of airplanes, and this is showing you altitude. Which of these airplanes might be smaller aircraft? Which might be larger passenger planes? I want you to take a few minutes and just answer these questions. Just jot it down right on your paper, and in a few minutes we will share. Go. All right, guys. What do you notice? What do you wonder? Let's start with that one. Cade.
Oh, I had one for the next one.
Okay, we'll come back to you. Hadley.
I noticed that BQ64 is at 36 altitude and it's at the highest.
Okay, so this looks like it has the highest altitude. Okay. What else do you notice or wonder? Jace.
I noticed that VT35 has the lowest.
Oh, okay, the one right above it looks like it has the lowest altitude. Okay, Coral.
I just forgot.
Oh, okay, Aaron.
I wonder why they used feet and not meters because of how high it could be.
It's a really good question. Did you remember?
Yeah. I wonder why they estimated this.
It looks like they did some rounding, doesn't it?
Yeah.
Yeah. Or maybe, yeah, because the chances of all of those being exactly on those benchmarks, well, maybe not. Does this number look rounded?
No.
Maybe not all of them. Okay. So which of these airplanes might be smaller aircraft? Kate.
I think the ones that go higher are smaller because, like, they aren't as heavy, and usually smaller planes can go higher and faster.
Oh, really? See, I don't know any of this.
Yeah.
Okay. Aaron.
Airplane history.
I think VT35 is one of the smallest because it has one of the lower altitudes.
Okay, or maybe it's the opposite. Maybe smaller ones can't go as high.
I mean, I do have a friend across the street whose uncle is playing Icon.
Which of these do you think might be a larger passenger plane? Charlie. WN90? Why? It just looks like it's probably large to you.
Yeah.
Okay, that's okay. Kaylin?
I think it's VT35
Maybe. And why?
because it has the lowest altitude, so it's probably carrying more weight with the passengers.
Okay. Keston?
I think NM44, just because actually, maybe I was thinking AL16
Okay, maybe this one.
because like it's in between the 15 and the 30,000. Well, not in between, but like it's like the medium of like.
I don't know the actual answers. I'm guessing we're going to find out. All right. So, this is our launch. Have you ever wondered how many planes are in the air at any given time? Have you guys ever thought about that?
No.
Do you know the answer?
No. But when we were at the airport, when we were waiting for a bus to come pick us up, there was a plane taking off and landing every like 90 seconds.
That's crazy. Trust me, I know there's plenty of planes because I live by the airport. And in the summer, when I'm outside, relaxing in the sun, it's like airplane. And sometimes they get pretty low, and I can just lay there and I'm like, whoa. Anyway, yeah, there's quite a few, and they go all different directions. What would be your estimate? How many do you think are in the air at any given time? What's your estimate, Hadley? Katie?
Probably like a million.
A million? Gage?
Like 3 million.
I don't know if there's that many.
Like in the whole
Brooks?
Is it like in the whole world?
It looks like it.
Maybe 1,220,000.
Goodness, you guys. Okay, so look at our next thing. One data source reported that in 2017, the number of planes that are in the sky at the same time ranged from 3,300 to over 12,000. You guys really had high estimates. I don't think there's millions, but 12,000 it looks like in 2017. Which, that's a good 5 or 6 years ago. With that many planes in flight at once, it is extremely important, as you guys can imagine, for planes to keep a safe distance from one another, especially around busy airports. So, what was I? Where was I? Was I on a plane? And the plane got too close to the other one. What happened? We were going down. Oh, I remember what happened. It was last year. We were coming back from Florida, and we were landing in Florida. We were going from here to Florida, and our plane was going to be too close to another plane, so they had us drop altitude really fast and then land. And you guys, I'm a chicken, right? Oh gosh, I screamed, grabbed, I was like, ah! And everybody else was like, whee! Bradley was having a great time, and I was like, we're done for. Yeah, that scared me to death. But But after everybody was done being freaked out because we just dropped altitude, when we were getting off, my husband, of course, asked the pilot, what happened there? Because that seemed out of nowhere. And he said that what happened is they knew he was going to be within however much distance that we can't be. And so the FAA said he had to drop altitude quickly to keep that distance. So that's a real thing. And you guys know I don't do roller coasters. And my stomach blew up. I was like, we're done. Whatever. It was fine. It was fine.
It's like the Tower of Terror.
It was the Tower of Terror for me.
I would have been like,
Literally, every other person on that plane was like, yay!
I would have been like,
Bradley was probably laughing.
All right. So what does this
I would
have
be
to
like,
do with math?
God.
I'll wait. Pull it together. Waiting. Okay. Let's see what this has to do with our math today. So, if we look at activity 1, page 75, right?
Yes.
It is called Apart in the Air. Altitude is the vertical distance from sea level. Here are the altitudes of 10 planes. Which planes are flying at about 30,000 feet? Explain or show your reasoning. Okay. What place are we rounding to? Okay.
10,000.
10,000's place. So, if we're looking at this first one, I have 35,625. Everybody, which digit is in the 10,000's place? The 3. I'm going to underline the 3. I'm going to look to the right. It is a 5. What does a 5 mean?
Round up.
Plus 1, right?
Yeah.
Okay, so what is this going to round to?
40,000.
And these all become zeros, right? So 40,000. So is this one going to round to 30,000? No. Okay. What about this one? What would you round? We have 28,999. What digit is in our 10,000's place? 2. If I look to the right, everybody add 1 or nothing.
1.
I'm going to add 1. The rest becomes zeros. So 2 plus 1 is 3. Everything else becomes a 0. Does it round to 30,000?
Yes.
Yes. Okay. Do you guys see what you're going to do for that part?
Yeah.
Okay. Then, question 2. Planes flying over the same area need to stay at least 1,000 feet apart in altitude. Remember we decided that's how you say her name? Mai said that one way to tell if planes are too close is to round each plane's altitude to the nearest 1,000. Do you agree that this is a reliable strategy? So you're going to write your answer to that. In the last column, round each altitude to the nearest 1,000. Use the rounded values to explain why or why not. The last column? Oh, is that where we were doing this part?
Yeah, put thousands.
So we're not supposed to do yes or no.
Yeah, but I don't know on the.
Well, then where would we do the...
You could say yes or no on half and then write the number on the other half.
You're not going to be able to write that small.
But it just says which planes are flying about
30,000. Well, where do you write that answer?
You would just use underline it.
area over here. Look at.
Do you guys just... Okay. So this is going to be actually rounding to the nearest 1,000, right? Yeah. And then over here, where I'm erasing, I guess you would list the planes that are at about 30,000 feet, which so far we know SK51. Okay, is it just one question we have to answer, number 2? Is there a number 3? Nope. All right, guys, I'm going to give you 10-ish minutes to do that. When you're done, come back to your floor spot. So head back to your seat and let's do that. And then we'll meet back here. All right. So this is our activity 1, synthesis. All right, raise your hand. How did you decide which numbers to include on your list of about 30,000 feet and which to exclude? So how did you decide which ones to be in that list? Aaron.
I decided by just looking at the numbers and seeing if they're closer or not. So I decided that SK15 goes in there. AL16, WN90, and NM44 goes in because they are all closest to 3,000.
Okay, so 30,000. So we're rounding, we're estimating. Our key word here is about. Do you guys agree with those 4 answers? Yeah, good job. Then, part 2, first of all, I want to know, oh, wait a minute. What was our next synthesis? Okay, who can give an example that shows Mai's strategy works? So for part 2, Mai said one way to tell if planes are too close is to round to the nearest 1,000. Do you think it's a good strategy, first of all? What do you think, Coral?
Yes.
Yeah? Okay, what do you think, Kara?
I think yes.
Okay. What do you think, Keston?
I think no, because you should probably be really specific while doing things like this.
I 1,000,000 times agree. I don't. We're talking about planes running into each other, right?
Mm-hmm.
I don't know if that's the time to be estimating. Okay. Yeah. Heather.
I agree with Keston because I would not trust a human to do anything and see how far apart a plane is from you.
Yeah, and I don't know that I understand why we're using this as an example, but okay. So our synthesis, though, says, who can give an example that shows her strategy works, and then an example that shows it doesn't work? So, who can give me an example that it works? Kara.
Because if you round it, they make it closer or farther away, so you can estimate and you can tell them to go apart or go closer or apart.
So, these 10 planes, this is where they're flying right now. I think that's what we have to imagine, okay? And I think my brain was struggling with that. What would you guys round this first one to? Just say it. 36,000. What about this one?
29,000.
Okay, then?
15,000.
Okay.
6,000.
Yeah, that one's already rounded for you.
31,000. 35,000. 17,000. 31,000. 30,000.
Okay, so that's supposed to be a 3. 30,000. Okay. Real quick, remember when we're rounding, everything to the right of that place value becomes a 0. Okay, so we're thinking about, which one shows my strategy works, okay? So if I look at this, I'm noticing that this plane, AB25, is 35,000, right? Well, I'm noticing BQ64 is 36,000. Are they 1,000 feet apart? Yes. So it looks like her strategy works, but does it really?
No.
Why not? Cade.
Because if you're like doing this with planes, like you have to be exact. You can't just be an estimate.
So if I was to subtract these, are they too close?
Yeah.
Yeah. So that kind of shows it doesn't work, doesn't it? What about these two? This one's 30,000. This one's 31. That's 1,000 apart.
No.
Would it work with those two?
No.
No. All right. Would it work with, what about this one that's 29,000 and this one that's 36,000?
That one would work.
Yeah, that would work. Are they more than 1,000 feet away from each other?
Yeah.
Yeah. So, really, I have to agree with Keston. Personally, I don't want you estimating when planes are too close to each other. Because if I was on that plane and it was too close to another plane, I would not be happy. Aaron.
I don't think it's correct because I think that even if they are thousands of feet apart and they're
Yeah.
not rounded, they're still a little close.
Too close. I agree.
Where they're like going like they can hit
Yeah.
each other if they're not if the
Well, and
pilots are careful.
even I'm thinking about the wind
Yeah,
factor.
it can like
Yeah. Yeah, Hadley.
I don't think I would trust anything to do it because
Don't estimate anything when Hadley is flying.
because I already get sick on the plane. Yeah.
Okay, interesting activity. Here's our next activity. How do you think pilots know whether their plane is too close to another plane while in the air? Kaylin.
So they have like a monitor that shows if it's too close and like the plane's coming in.
Okay, so a little gadget or a little instrument. Okay, Keston.
I have a radar.
A radar that's
Yeah.
like a little blippy thing. Yeah, radar thing. Okay, Vivian.
They literally see the plane and they're like, nope.
You know, I think you're two eyes. Jace.
I think it depends how, like, if it's super close and you can see and you can't see the whole thing, I think it's too close. Or, like, if it's, like, this big, you're fine.
I don't know about you guys, but if the pilot is going, there's a plane over there, I don't know. We might be good. I don't know if that would make me feel very comfortable.
I would just
So, we have these things called air traffic controllers. And they're a group of people whose job is to monitor air traffic, including to track the positions of all the planes and the distances between them. That makes me feel good. Somebody's job is to actually monitor that. Doesn't that make you feel a little bit better? It's not the pilot going, I don't know, we're a little close. So let's see what you're going to do with this. What page are we on? 76?
Yeah.
Okay. So you're going to use the altitude data table that we just filled out. And it says, look at the column showing exact altitudes. A, find two or more numbers that are within 1,000 feet of one another. Mark them with a circle or a color. B, find another set of numbers that are within 1,000 feet of one another. Mark them with a square or a different color. Based on what you just did, which planes are too close to one another? Then you've got some more questions to answer. repeat what you just did with the rounded numbers in the last column. If we look there, which planes are too close to one another? Number 3, which set of altitude data should air traffic controllers use to keep airplanes safe while in the air? Explain your reasoning. And 4, are there better ways to round these altitudes, or should we not round at all? Explain or show your reasoning. Hadley.
None of us have a chart.
So you're supposed to use the chart from the last activity. Okay. So you're going back because you've already, guys, you already rounded those numbers. So you're basically comparing the exact numbers to the rounded. That's what you're doing. Okay. So, I think you should head back to your seat. I think you can do this one on your own. If you're stuck, grab your math partner. When you're done, come back to your floor spots. Let's head to our seats. 10-ish minutes. Okay, we're going to go over this. All right, so, guys, for the first one, you're going to find 2 or more numbers that are within 1,000 feet. So if I come back here, I'm going to erase these. Okay. All right. We're looking at exact numbers. Give me a pair that are 1,000 away from each other. Jerica.
More than 1,000 away from each other?
I already forgot.
Just 1,000.
Within 1,000. So they'd have to be less than. Within 1,000. Which 2 would you say? Just tell me your 2. Yep, they're within 1,000, aren't they? Okay. Then, what did it say? Find another set. So there's more than one answer, right? Yeah. So then the other set, you'd put a square or use a different color. Bella, what did you say?
I said VT35 and CM48.
Yeah, they're within 1,000, aren't they? Pretty close. Well, they might be. No, those are a little bit more than 1,000, aren't they? We want within. You were super close. Riker.
Your M44 is W990.
Aren't they about 500 apart?
Yeah.
Yeah, that's. I don't think I would want those 2 planes. They are in violation, aren't they? Okay, that's all you had to do for the first part. Then, based on what you just did, now you're going to decide. Oh, I kind of answered it. Which 2 planes are too close to each other?
WN90
And
NM44. Wait. What did we just? Oh, they're right here. WN90 and. Yeah, are those the only ones that are too close? Because our other set, they are, well, this set is also too close, aren't they? Our circles, aren't they like 500? So we would also list both of those, wouldn't we?
yes.
So what was that, WN11? And AB25. Does that make sense? Okay. So that's all you had to do for number 1. Number 2, says repeat what you just did with the rounded numbers. So now I'm looking at my rounded numbers. I will use a different color. All right, and looking at my rounded numbers, guys, which ones are within 1,000 of each other? Madeline?
31,000, 31,000.
Oh, gosh. Right? Big erasers.
Like the ones, like Mr. Lemming has it on it.
I don't. You could go ask him for one. Just don't interrupt him. Okay, Hadley?
36,000, 36,000.
This is kind of sloppy, but can you guys see?
Yeah.
Okay, Aaron?
Not most of the others because they're all separate. None of the others.
So is that it?
Are separate.
Yeah, they all look like they're separate, huh? Very interesting. Sorry, guys. If there was a quicker way to go back and forth, I'd do it. So, oh gosh, so which planes are too close to one another? Can you read me our answers we just did? Or do I have to go back? Which ones, Coral?
Oh, the numbers that we just did?
The name of the planes. It says which planes?
AL, 1, 6.
Okay, and which one was it too close to?
W and negative.
Okay, what was our other set of planes, Madeline?
WN11 and BQ64.
BQ, was it BQ?
Yeah.
64? Okay. So, based on that, do you think traffic controllers should be using rounded numbers or exact numbers?
Exact.
Does everybody agree exact numbers? Yes. Okay. So, exact. Are there better ways to round these altitudes, or should we not round it all? What do you think? Madeline?
I don't think we should round at all because if we round, then they might be like too close. But we wouldn't see that because they rounded.
Yeah, I mean, look at this example. I'll grab another color. Look at this example right here. Okay? When we looked at exact, we said AB 25 was too close. But when we rounded, we said no, AL 16 is too close. Would you want to guess, not guess, would you want to say the wrong plane is too close?
No.
No. What do you think, Aaron?
No, because, hold on. You should not round at all because then you do not get the right data and you can't, and you can't keep your drivers, and you can't keep your pilots safe.
Right. Well, you want to keep your passengers safe too, right? Poor Mrs. McElroy back there like freaking out. Chase, last comment.
I say no because if they do it, they do the like tens thousands and like it's 28, 8 and 29 and something, and one rounds to 30 and one rounds to 27. Those planes could crash.
Right. Do you think it's worth the risk?
No.
No. Okay. I think we just synthesized, didn't we?
Yeah.
All right. So, yeah, we just did that. Guys, you have a third activity. In the United States, air passengers are not permitted to use their cell phones from takeoff until landing because phone signals can interfere with flight communication signals. However, this hasn't always been true. There had been a time when phone use was allowed after the plane reached a certain altitude. Some countries still allow phone use, based on the altitude of the plane. What do you notice? What do you wonder?
Do you want to draw like a big circle? Okay.
What do you notice or wonder? We're looking at this table. We have planes, A, B, C, D, E, F, and we have their altitude. What do you notice? What do you wonder? There's no right answer, no wrong. Brayden, what do you notice?
I noticed that there's letters.
Okay, instead of those plain letter number thingies, now we just have letters. Hadley. I think so too.
A lot of the plane altitudes are really close to each other.
Yeah.
Except for the 30,000.
Yeah, most of them are a lot closer than our last chart, right? Coral.
That plane A is the highest, highest altitude
Yeah.
in feet.
Okay, let's see what we're going to do with these. Jada says the passengers in all planes except plane F can use their phones. Oh, I forgot to read this. In some countries, cell phone use is allowed on a flight only when the plane is at a certain altitude, usually 40,000 feet. 6 planes and their altitudes. Okay, so Jada says the passengers in all planes, except for plane F, can use their phones. Do you agree?
No.
Hadley.
I agree with her because if you rounded all the rest of the numbers,
Yeah.
you would basically go to 40,000 if you're rounding 10,000.
So if we were to estimate and round, then she would be correct. Okay, Eric?
Well, I agree with her because our lesson is about rounding, and
Because you figured me out, huh?
and 6 and 9 and E they all round except for F because the others will all round.
So let me ask you this. For this to be true, what place did Jada round to? Riker.
10,000.
The 10,000s. Do you guys see that?
Yeah.
So Jada must have rounded to the 10,000 place. Then Elena says only those in B and D can use their phone. Okay, well, what place value did Elena round to? Kira?
She rounded to 1,000.
She rounded to the thousands, didn't she? Do you agree with either of them? This is what do you think? Kaylin, do you agree with either of them?
You round to about 40, usually, you talking to usually around 10,000, you, going around the 10,000, so, all of them round to 40,000 except F.
Yeah. I don't agree with either of them.
Same.
But that's because I think when it comes to airplanes and flying, we should be using exact numbers because I'm afraid of flying. So, okay, we're about to run out of time. All right, so that was kind of a quickie. Today, guys, we used rounding to make sense of these situations and solve problems. Okay, so let's see. Here's your cool down. Oh gosh, we're looking at airplanes again. So planes are too close when their altitudes are within 1,000 feet of each other when they fly over the same area. Jada says planes C and E are too close. Noah says C and E are a safe distance apart. It says use rounding to explain how both statements might be correct. A little bit of a challenge. All right, you're going to do your cool down, you're going to turn it in, and then you should read. You may silently head back to your seat.